Right. So now flowchart. I reserve flowchart for last because I believe it's kind of interesting. We are going to have a lot of fun. Some sort of fun. It depends. But have you come across something like this before? Or something similar? When you walk to the bank, do you see any inscriptions around directing you as to where to stand, where to go next? Where else do you see some of this stuff? Let me know in the comment section as well, right? Yeah, I like us to be very interactive. So just let me know where you find some of these symbols, all right? But this is a form of flowchart. So if a flowchart is where now this time around we are not using just text, okay? Here we are doing a pictorial, so pictorial representation of algorithms. So here we use shapes and symbols to represent set of instructions, and that is a flowchart, as you can see in this diagram over here. So here you're seeing this an instruction for washing your hands. So step one, you wet your hands, you apply soap, you scrub for 20 seconds, you rinse, you dry, you turn off the water, and all of that. Yeah, great. I hope you guys wash your hands often. You know, it's pretty good to keep yourselves safe, right? Okay, but this is more of like an informal kind of like a flowchart. Okay, so a practical or a more technical flowchart in our domain, and when I say in our domain, I mean the programming domain, is going to look something like this. Yeah, so here where you have a step, you have a start, you have a step one, a certain decision somewhere, a step two, and then the end over here, right? So if you remember from my initial definition of flowchart, I mentioned that is a pictorial representation of algorithms, right? Where we use shapes and symbols to represent set of instructions, okay? But, you know, if we allow everybody to use any shape or any symbol at all to represent the algorithms, then we are going to have an issue here. We're going to have a wide variety of algorithms that will be difficult to explain, right? Because the shapes I'm going to use will be different from yours, and then I might not be able to clearly understand what you mean. Because of that, we have standardized shapes and symbols that we use whenever we want to create flowcharts. All right, flowchart. So we are going to walk through some of these shapes or some of the shapes, and then we'll look at how we can use them. So straight away, let's move along. So the very first shape you are going to look at is what we call the terminator. All right. So the terminator is usually we usually use an oval shape. Okay, you can have an oval, maybe an ellipse, sometimes a circle to represent the terminator. And the terminator is simply just used to indicate the beginning or the end. So the start and the stop of the algorithm. That is when we use the terminator. That's what we use the terminator for. We also have a rectangle. We use the rectangle to represent a process. Okay, so the process here is we're talking about stuff like calculation. When you are maybe move this from this to that, you know, an activity that does not involve output or input. I think in pseudocodes, I explained to you what the input and the output were. So if it is not, you're not taking information or data from the user, and then you are not displaying anything to the user, then whatever activity that you have there is some form of a process. Okay. So we use a rectangle for that. Now, sometimes you need to take decisions in your programs. So to take decisions in your program, we use what we call the decision box. Okay, in other materials, you're going to see they refer to it as the diamond shape, right? So we use that to indicate the decision. And then we have this one, this shape right here. I'm going to try really hard to give you the name of this shape. It's called the parallelogram. I said it. I did it. It took me 3 years to learn how to pronounce that, but I'm not repeating it again. Yes, that's the shape. We use that to represent both input and then also output. We also normally refer to it as data. Okay, so whenever you are taking data from the user or you are sending data to the user, so taking from the user or giving to the user. All right, so when you are taking from the user, that is an input instruction, you remember, from pseudocodes. And then when you are giving data to the user, that's when you are giving feedback or information to the user. That is an output. So you can see that for the parallelogram. Wow, I said it twice. So you guys should be giving me some likes, right? And then don't forget to share as well. So we use that one for both input and then output, just like we have the terminator doing two jobs, the start and the stop, right? Okay, and then we have this shape right here called a document. So if, for example, the output or the data that you are giving to the user is in a form of a document. So for example, at the end of your program, you're going to print out a hard copy document, like, print out something like a document. Or maybe you are going to generate like a file, like maybe a picture, something like that. That is a document, right? It's not just text you are showing on the screen. Then in this case, we use this shape, the document shape. Most of the time, we use it in conjunction with the data shape as well. So we have the data shape as the main shape, and then we have this one on it just to indicate that this shape is a document process, or is giving out a document, okay, or maybe taking in a document, something like that. And then most importantly, we also have the arrows, okay? So the arrows are what gives, so the arrows is what gives us the flow, right? The arrows indicate the flow of the instructions. So maybe from this shape, and then the shapes represent the instructions. So from this shape, we are moving to this one. That means from this instruction, we are going to this instruction. From that, we are going to that, okay? So that gives you the flow, all right? So the shapes are the charts. Okay, the shapes are the charts, and then the arrows indicate the flow. So when you combine them, when you link the charts using arrows, then you get a flow chart. Cool, right? So based on the descriptions of the shapes or the charts that I have given you, can you convert our pseudocode for adding two numbers into a flow chart? Can you do that? Let me give you a hint. So you don't just use the shapes, but once you have the shapes, then you also need to put some form of inscriptions or descriptions inside the shapes, okay? And they are just the text that you have from your pseudocode that you transfer to the shapes, okay? So that is just a hint. So give it a try, and let's see what you come up with. So if I'm going to go by the second pseudocode, the second solution that I provided, then our flowchart is going to look like this. So you have your start, and you remember we have the start in an oval or an ellipse. So we have our start, and then right from our start, we move on to our input statement, where we input two numbers, number one and then number two. Right, so you see that over here, I'm doing both inputs in one instruction, and I think I clarified that when we did the example with the average of two numbers, where I said where we had three numbers, we did three inputs, and I put all of them on the same line. So we can have the same logic over here in the flow. That's the same logic we have in the flow chart. So we are taking two numbers, so we just did input number one, number two. And you see that over here, we are using the input keyword, the keyword input. So because the parallelogram is used to depict two separate actions, both input and output, anytime you use it, you have to indicate which of them you are using it for. So in our case, in this first one, we are using it for an input. So we have to indicate, you have to specify input. And when we input, where do we want to store? We want to store it in maybe number one and number two. So you see that over here now I'm using number one and then number two instead of N1, N2. So what happens after I've taken the numbers? After I've taken the numbers, I need to do some form of calculation. And since I'm doing a calculation does not involve me giving data to the user and then taking data from the user. I've taken the data already. So now I'm working with the data. So I'm performing a process. So now I'm going to use a rectangle. Is that right? I'm going to use a rectangle for that. And then once I'm done with my calculation, I have to print the results to the user. If I'm printing or I'm displaying the results to the user, then I'm going to use an output statement. And you remember that some of the output statement, the keywords we use for output statement are keywords like output, write, and print, right? We also have display. So here I said print sum. And once I'm done, I just end my program. Okay, and you see over here in this flowchart, I used start, but I didn't use the stop. Okay, but ideally supposed to use start and then stop, or begin and then end. But this is just fun. Like I said, this is not a hard rule, right? It is more of a recommendation, so it is okay. So how does your flowchart look like? Did you separate your input statement? What other methods did you use? Let's get interactive, all right? So this is just a simple flowchart, but a flowchart can also look like this. Yes, we can have a flowchart that looks like that, but don't worry. Once you understand the shapes and you know what exactly you are doing, then you can be able to interpret whatever is happening or going on over here. All right, so let me know the kind of examples you want me to solve. I'd like to do another video just fully on pseudocodes and flowcharts, just examples, where we are going to look at other stuff like the conditions and other stuff, right? And some other programming concepts. But once in a while, as we are going through the playlist, we'll come back to some flowchart, because as we are solving some practical C++ examples, we'll be drawing some flowcharts and writing some pseudocodes. So don't worry about it. Just stay in touch. Subscribe to the channel. Make sure you click on the notification icon to be notified whenever I release new videos. Also share this video with your colleagues, both in your school and outside your school, okay? So they can also learn a thing or two from us, all right? Cool. So far, we have learned 3 different ways of representing algorithms, right? But when do we use which? Because we can see that all of them are different, yeah, very different. So when do we use NLAs? When do we use pseudocodes? And when do we use flowcharts? Okay, so let's quickly run through some of the pros and cons of each type of algorithms, all right? So NLAs are expressive, so they are relatively easier to write and understand, okay? You do not need any technical knowledge for you to be able to write natural language algorithms, right? So this means that if you have non-technical people that are not really into programming or understand the concept of programming, and you want to relay information to them or relay some programming concept to them, then it is better that you write these algorithms in natural language algorithms, because then it is easier for them to read and then to understand, okay? In this way, non-technical people can also be able to, in some way, write some algorithms and or make suggestions to programmers, which they will now convert to actual programs. Nevertheless, because we are just using our regular language to write it, it can be ambiguous, all right? Because some of the terminologies I might use, it will be difficult for other people to understand it, right? So it can also lead to misinterpretations and sometimes errors, okay, or implementation errors when an actual programmer is now trying to implement them, because because of the high ambiguity, okay, then the implementation errors also becomes high because there's a lot of misinterpretation. So now let's look at flowcharts. Now flowcharts, they use visual representations which further describes the flow of the process, okay? So it is also simple and easy to understand, right? But then you have to understand the shapes and know which one to use at any particular point in time. Other than that, you end up with misinterpretation issues as well, right? So for example, when you have the parallelogram representing both input and output, if you are not careful with the keywords, then you might make an output statement look like an input and vice versa. So for complex algorithms, poorly designed flowchart can look really messy and difficult to interpret. Something like this, right? Especially for novices, people who are just starting out, right? Yeah, but don't worry about that. I'm sure your algorithms will look much, less intimidating than this ones. So now let's look at pseudocodes. These guys, they behave like code, although they are not. That's where they get their names from. Pseudo, behaving like, acting to be like code, but they are not code. They are not code. They are not code. So their structure pretty much looks like an actual programming code. If you know some form of programming, you'll see that when you structure a pseudocode really well, it looks like code. Okay. That is because they contain programming constructs like variables and the keywords and those stuff. Okay, because of this, it makes it really easy to translate pseudocodes into actual codes. However, they are relatively more difficult to construct than natural language algorithms and even flowchart. Okay, that's because you need to know how to. You have to understand these programming concepts that you have to integrate, and then you also have to be able to trim down the natural language to very concise forms. Okay, so it's very technical. So when you give a pseudocode to a non-technical person, they find it really difficult to understand it. So when you are at a point where you're just about converting your ideas or your algorithms into actual code, then it makes much more sense to use pseudocodes. Okay, because then you know the keywords to use and the specific programming constructs or logic to implement, right? Yes, so that is for pseudocode. But then when you have just rough idea, just trying to sketch or put together your ideas, then it will be better to start with the natural language, move through pseudocodes, or maybe move through flowchart and then pseudocodes. Then right after pseudocodes, you get your actual codes. Cool, right? So far, so good. We have come a long way. I'm really proud of you for sticking around for this long. Yeah. So just to recap, today we looked at algorithms, what they are, how to write good algorithms, how to represent algorithms, right? So we have looked at natural language, we have looked at flowcharts and then pseudocodes. We have looked at the pros and the cons of each of them and when to use which, right? Yeah. So let me know your favorite algorithm. I happen to like flowcharts. Yeah. I used to be called a flowchart engineer back a long time ago, but yeah, maybe you can also be a flowchart engineer. Yes, but let me know your favorite algorithms. Yeah. Sorry about that. Yeah. But of course, let me know if you need me to make additional videos on pseudocodes or flowcharts. If you have specific questions that you need me to, or examples that you need me to create videos on, of course, let me know. I'll gladly do that for you. But if you haven't subscribed already, please subscribe and then click on the bell icon to be notified each time I release a new video. Okay. Also, like this video and then share, okay, to your colleagues in other schools, in your same school, wherever, just share. Okay. So we can all learn together. All right. But I'll be really happy to hear from you. What have you learned? What do you want to see in the playlist that I've just created? What are some of the topics that you are eager to see on the playlist? And what are some of the other stuff that you need me to make videos on? Of course, let's get interactive. And if you like the beat that I'm using in my intro, of course, you can hit me up. I might give it to you for free, right? Okay, so I think this is where we end. I'll see you around in the next video that will be coming soon. Expect it within the next week. Stay safe. Let's view the world in a technological way. Peace out. Just believe. I love you all, man.